Okay, so for this one, Newman projection. So we're gonna do an E2. So we're gonna have a large, bulky base that's reactive. Right. So a large, bulky base that's reactive. But this conformation, as it stands right now, is not. This is not. Okay, so the way this is at right now, though, is not an anti-periplanar conformation. We gotta get the leaving group and the beta hydrogen, in this case, to be 180 degrees apart. So the first thing you need to do is just draw the Newman projection. So we gotta decide what kind of Newman projection we have. So if you're standing here looking, if I call this carbon 1 and carbon 2, so the front one is 1. There's something at my feet. It's an eclipse conformation. Hope you can see that. So H was here. I have bromine on my right, and it's ethyl. And down here I have an H, which is on carbon 2, which is on the back. I have the O there, and then let's see. I have another methyl here. Okay, so what I need to do though, I need to get the bromine and this H on carbon 2, right? This bromine and this H to be anti-periplanar, so I need 180 degrees apart. So I'm going to choose to rotate one of them. I'm going to rotate the back one just 60 degrees. So clockwise 60 degrees, let's say. So clockwise 60 degrees. So I'm going to keep the front one the same. I'm not going to change that at all. And I'm going to rotate the other one so I get to a staggered conformation. Alright, there's 1 and 2. And so now what I have these two in an anti-periplanar conformation. Anti-periplanar conformation. And so now, if I draw what they're going to make on carbon, if I call this carbon 1 and this carbon 2, so carbon 1 still has an ethyl and an H on it. So I'm going to put the ethyl here and the H here, just arbitrarily chose that. But then when I look here, I said, okay, well, the ethyl was on the same side as the ethyl on carbon 2. So carbon 2 has the O methyl and this methyl here. But it looks like the ethyl and this O are on the same side. So I need to draw them on the same side of the pi bond. And this H and this methyl on the same side. So I need to draw them on the same side of the pi bond. So that's the key, is that couple parts. Draw this, right, Newman projection. Get it so the leaving group and the beta hydrogen, not this hydrogen, the beta hydrogen, are anti-periplanar, right? And then draw it out. Draw the pi bond that you're making with those things in the right spot. Okay, let's do like a chair flip to make sure things are axial equatorial and like do an E2 practice. First thing I'm gonna do, just do a random thing. I'm gonna number these carbons. And I'm gonna draw a chair. Remember, every one of these has 2 different types of chairs, right? And so I'm gonna draw one. We'll do our numbering. 1, 2, 3, 4, 5, 6. So carbon 1 has a methyl that's up. Axial, equatorial. There's a bromine that's down, and H that's up. Then 5 had an ethyl that's up, right? So I just got lucky here, and I drew the bromine is axial, right? My leaving group is axial. I could have drawn it lots of different ways, made the bromine equatorial, but the biggest thing, the way I draw these, if it's dashed, the bromine's down. Dash means down to me. Wedge means up. Just gotta be consistent. So I have this axial. So now what do? We look for beta hydrogens. So beta hydrogens are hydrogens that are 1, 2 bonds away. 1, 2 bonds away. So does carbon 1 have any beta hydrogens? It doesn't, right? So if there's no beta hydrogens there, right? These are right? This is a CH3. Remember one of the first things I told you, if it doesn't have beta hydrogens, it can't do eliminations. Got to have beta hydrogens, otherwise it can't do it. Now in 3, it has an H that goes up and an H that goes down. So that's the only one that would work. So if I drew some imaginary base, it'd go for that H, and that would lead to the pi bond. I can draw it either way is fine. The pi bond is now there. Alright, between 1, 2, 4, 5, and 6. Obviously 1, 2, 2, and 3. Again, you got to get the leaving group axial. Whatever way. If it's up, you need to look for beta hydrogens then, or down. They're also axial. It have to be everything has to be axial and opposite sides. But you have to have beta hydrogens to eliminate in the first place. So like carbon 1 here doesn't have any beta hydrogens. It won't work.